Okay, let's jump right into this explainer and talk about arguably the greatest astronomical mystery of 2017. I want you to imagine a completely unprecedented visitor tearing through our solar system, behaving in ways that totally defied our standard models of physics and astronomy, and then disappearing back into the void almost as quickly as it arrived. Well, today we're cracking open the case file on 1I/Oumuamua, the very first confirmed interstellar object to ever visit our cosmic neighborhood.
All right, take a look at this number, 1.20. Now, in celestial mechanics, that is an orbital eccentricity value. You see, most planets and asteroids in our solar system have eccentricities pretty close to zero, which just means their orbits are roughly circular, and they're bound by the sun's immense gravity. But a number above 1.0, that means an object is on a hyperbolic trajectory. It mathematically proves that an object is completely unbound to our sun's gravity. So when astronomers calculated a 1.20 for this object, it was the highest eccentricity anyone had ever observed. It was absolute undeniable proof that this thing was not from around here.
And that really sets the stage for our cosmic detective story. What actually happens when an object enters our solar system, traveling 58,000 miles per hour straight from the direction of another star? This object plunged into our neighborhood from roughly the direction of the star Vega, over in the constellation Lyra. It had a hyperbolic excess velocity of over 26 kilometers per second. Yeah, that's roughly 58,900 miles per hour, relative to the sun when it was out in interstellar space. So as we investigate this first known interstellar visitor, we have to ask ourselves, how in the world did it get here? What is it made of? And most importantly, why did it behave so strangely? Which brings us to Section 1, the first distant messenger. Looking at the timeline of events, this object was incredibly stealthy. I mean, it actually reached its closest point to the sun, known as perihelion, on September 9th, passing about 17% closer to the sun than the planet Mercury. But get this, nobody saw it. It wasn't until October 19th, literally 40 days after it had already whipped around the sun and was speeding away past Earth, that Canadian astronomer Robert Warwick finally spotted it using the Pan-STARRS telescope in Hawaii. Because it was the very first of its kind, the International Astronomical Union actually had to invent a brand new I classification for interstellar objects. They named it ʻOumuamua, a Hawaiian word that roughly translates to a scout, or the first distant messenger reaching out from the distant past. And when you compare its speed to local, extreme outer solar system objects like Sedna or even standard comets like Leninin, it's just mind-blowing. Their inbound velocities are usually hovering right around 2.6 to 3 kilometers per second, but Oumuamua's inbound velocity, an impossibly fast 26.55 kilometers per second. It was moving way too fast to have just been bumped out of our own Oort cloud. No, this was a true galactic drifter. Moving on to Section 2, a bizarre cosmic profile. So the most striking physical feature of this thing was definitely its shape. While it just showed up as a single, tiny point of light in our telescopes, its rapidly shifting brightness told a completely wild story. Astronomers basically concluded it was either an extremely flattened pancake or a giant cosmic cigar up to 1,000 meters long. The length-to-width ratio could have been as extreme as 10 to 1. This highly elongated shape immediately prompted some playful, and honestly, sometimes serious, comparisons to the alien spaceship from Arthur C. Clarke's sci-fi novel Rendezvous with Rama. We had literally never seen a natural solar system object shaped quite like this before. And adding to that bizarre profile, it wasn't just spinning smoothly on an axis like a top. Instead, it was tumbling through space, which is what physicists call non-principal axis rotation. Imagine tossing a coin in the air and having it flip chaotically in all 3 dimensions at once. That was Oumuamua. Its brightness varied wildly every 7 to 8 hours as different, drastically disproportionate sides caught the sun's light. This tumbling motion is a massive clue, by the way. It's highly likely the result of a violent collision that occurred billions of years ago when this object was first ejected from its home star system. And then there's the composition. Telescopes picked up a reddish hue, which is indicative of organic compounds called tholins that have been irradiated by millions of years of cosmic rays. But here is the major astronomical contradiction, the real head-scratcher. Despite passing incredibly close to the scorching heat of our sun, this object produced absolutely zero visible dust, and no cometary tail or gas cloud, which we call a coma. If it was a standard comet full of surface ice, the sun absolutely should have boiled that ice off into a massive, highly visible tail. But Oumuamua? It remained completely naked and dry, functioning much more like a dense, rocky asteroid. That leads us right into Section 3, the unexplained speed boost.
17. That's the exact number of extra meters per second of speed that Oumuamua inexplicably gained as it was leaving the solar system. In June 2018, astronomers reported a non-gravitational acceleration, meaning the gravity of the sun, the planets, and literally everything else we understand about celestial orbital mechanics could not explain this extra push. Something else was hitting the gas pedal. Now, normal comets actually accelerate non-gravitationally all the time. When their internal ice heats up, it boils off and shoots out like a jet engine, creating a beautiful, visible tail and altering their trajectory. But Oumuamua managed to accelerate while remaining completely invisible, no tail whatsoever. Furthermore, standard outgassing on a chaotic, highly elongated tumbling object should have rapidly spun it out of control until it literally tore itself to pieces. Yet Oumuamua maintained its stable, chaotic tumble. It was essentially the very first of its kind, a dark comet. Which brings up some wild theories in Section 4, icebergs, comets, or aliens. The scientific lineup of suspects here is absolutely fascinating to look at. Some scientists proposed it was a giant chunk of nitrogen ice, basically a sheared-off fragment from an exoplanet similar to Pluto. Because nitrogen is invisible to our telescopes, it could outgas and provide the thrust without leaving a trace. Others suggested hydrogen ice, formed in the deep freeze of a giant molecular cloud. A newer 2023 theory suggests it's actually standard water ice, but cosmic rays over millions of years altered the ice, trapping molecular hydrogen inside that then released as it neared our sun. And then, of course, there's Harvard astronomer Avi Loeb's controversial technosignature hypothesis, the idea that Oumuamua's acceleration was driven by solar radiation pressure pushing against an artificial, ultra-thin solar sail created by an extraterrestrial intelligence. Now, while Loeb's alien solar sail theory is definitely considered unlikely by many experts who lean toward those exotic ice models, this quote from Loeb perfectly captures why this whole debate actually matters so much. Regardless of which specific theory ends up being totally correct, this object proves the existence of entirely unknown, wildly exotic cosmic environments. Whether it's a piece of an alien Pluto, a chunk of hydrogen ice from the deep void, or something else entirely, Oumuamua is a messenger proving our universe is just far more diverse than we ever imagined. Let's wrap things up with Section 5, chasing the next interstellar visitor. Because it faded from our telescopes so incredibly fast, we were left with pretty limited data. But the Initiative for Interstellar Studies? They are not ready to let the trail go cold. They launched Project Lyra, which is a feasibility study to send a spacecraft out there to literally chase Oumuamua down. While it's moving unbelievably fast and has a massive head start on us, theoretical missions utilizing advanced tech like the Space Launch System, Jupiter Gravity Assists, or even laser sails are currently being designed. A successful intercept in the coming decades could give us our very first up-close look at a piece of another star system. But honestly, perhaps the biggest takeaway from all of this is that Oumuamua wasn't just some one-off anomaly. It was a door opening. By 2024, astronomers had already identified 14 local asteroids exhibiting similar dark comet behaviors. More importantly, we now know exactly how to look for these interstellar visitors. In 2019, we discovered 2I Borisov, a highly active interstellar comet. And looking forward to 2025, we have the expected arrival of 3I Atlas. We literally have an entirely new, rapidly growing subfield of interstellar astronomy on our hands. So I want to leave you with this final thought. For centuries, we viewed our solar system as this somewhat isolated, closed bubble. Oumuamua shattered that illusion completely. We are actually sitting in a very busy cosmic intersection with fragments of distant planets, ancient molecular clouds, and maybe things we can't even dream of yet, constantly zooming right past us. If Oumuamua was just the first distant messenger we managed to catch in the act, what is the universe sending us next?